Hello everyone, my name is Satish Kale. I head the Specialist Solution Architect Technology team for North America Telco for Red Hat. I have worked with Red Hat for more than 12 years and I have a total 20 plus years in IT industry, mostly working in various capacity as a developer or a project manager, product development, chief architect, etc. Today I'll be talking about IT modernization. Modernization is not just a destination but a journey. In this, one of the major aspects is of application modernization. This is where the emerging topic of microservices gains importance. So today in this session, I will cover the modernization journey with respect to moving from monolithic architecture based applications to modern microservices architecture based applications. I will address any questions you may have at the end. So today's agenda is like this. Okay, I will be cover why this modernization related changes is necessary. Then I'll cover it in context of some common use cases. Then I will cover the topic of architectural considerations for this modernization. Subsequently, I'll introduce some Red Hat technologies, tools and processes for why Red Hat is relevant as a partner in this journey. Later, I will cover a very interesting topic of future ready options, and then I will talk about modernization approach. Finally, ending with summary and Q&A. Before we look at how, let's look at why modernize. Okay. Digital transformation is all about accounting for business disruption. They are no longer just traditional business competitors. Over-the-top players, digital service providing content through various options. This has made the current setup unsustainable, where you are expected to create new business services faster, consider customer feedback and demands, and then adapt accordingly. So this digital transformation has ensured that companies take core intellectual assets and turn them into a software. Companies are now competing for the new value that their software provides, and to succeed they need to build the software faster. This is changing the entire IT landscape. So it's no surprise that during this disruptive times, many high-performing organizations are outperforming their competitors, and they are doing it substantially. The following are the numbers from the 2017 Puppet Labs, the State of the DevOps report. The results show that high-performing organizations deploy 46 times more frequently than low-performing ones. They also do 5 times lower change rate failures. And in case there is a problem, they can recover 96 times faster. The good news is technologies and principles that were adopted early by these challenges are available to mainstream and traditional businesses. Now let's talk about media challenges and market demands that create a new reality. So transition from hardware appliance models to efficient cloud native model, that's a reality. Achievement of having an infrastructure cost saving or open vendor choice so as to using any commercial off-the-shelf hardware, which is a commodity hardware. Then this journey to hybrid cloud computing, which comprises of first virtualization and then eventually containerization. Then the acceleration of channel deployment so that provisioning time is reduced and deployment is simplified. So channel deployment needs to happen in a matter of minutes rather than hours, weeks or days. The other thing is about ability to quickly and easily enable new subscriber services so as to maintain and grow your subscriber base through multiple screens. The last but not the least is enhancing quality of service for the service delivery and quality of experience for the subscribers. As I said earlier, modernization is a journey. There are many facets to this journey. The infrastructure modernization involves moving from on-prem data centers to the hosted to the cloud-based. Development process has progressed from waterfall methodology to agile to DevOps. The development and packaging strategy has changed from physical servers to virtual to containers. Similarly, the application architecture has moved from monolithic to n-tier and finally to microservices based. Today we'll be focusing mostly on this part of this modernization journey. However, before we move on, the why needs to be understood better. It is very important we succeed at digital transformation. For this, we need to do things differently. So we need to rethink how to build and deploy the software. The needs, okay, that are related to this are you need to build it much faster. That means build and deploy your software much faster. You need to be more agile, making changes to the application more frequently, change infrastructure more dynamically, and also to make it more efficient. So that means run software more efficiently at lower cost, create applications with fewer resources. These are the 5 top challenges our customers and our peers say that they are facing. Optimizing existing traditional resources so they can continue to add value. Integrating old and new systems, resources and processes. Adding and managing the cloud infrastructure. Building modern applications and solutions that innovate your businesses. And then automate as much as possible so as to have a self-service kind of environment which can do auto scaling, auto healing and workload optimization. Beyond technology, I would add a 6th category here, which is cultural changes. If your processes between business and IT still contain the old bottlenecks and manual approvals, that will slow you down. It doesn't matter how amazing and efficient your apps and infrastructure are. You need to address that particular part. The transformation requires cultural and processes changes to support these new ways of working. As I said, cloud can't solve every challenge, and neither can simply improving our existing infrastructure. This is why both modes, mode 1 and mode 2, need to exist. You must create or improve the tools, processes and systems for which and on which the modern applications can be built to support this digital transformation. Does this picture look familiar? Okay, where does the journey starts for most? When we talk about optimization of applications, we also need to talk about infrastructure environment it is running on. Let's have a look at the typical customer landscape. We will find an existing application portfolio that has grown over the years. Let's call it brownfield. Different runtimes, technologies, custom self-written applications, packaged software, etc. The portfolio grows by either adding new capacity to the existing applications or developing new apps the traditional way. And many organizations are doing some more transformative stuff. If you look at the infrastructure, it's often physical or virtual for the more traditional stuff. Sometimes private cloud and some public cloud also. The problem with this is it's complex and heterogeneous. There is often a lack of common standards. There's inconsistency in automation and governance depending upon which pieces you are looking at. And often there is a room for better automation. Now what do? How do you cater to both? So you need to know that they need to modernize existing applications, and you would like to start developing new applications like the modern way, maybe with an application runtimes like Spring Boot, Node.js, or fully cloud native leveraging both the cloud and containers. But how can you do that without adding more complexity and inconsistency? So let's talk about application portfolio modernization. Okay, so wouldn't it be nice to have something like this? You would still have your application portfolio, which is now modernized, brownfield, okay, which will be growing your existing and adding new modern applications which are more greenfield. You would want an infrastructure that allows you portability across physical, virtual, private cloud and your preferred public cloud, or support hybrid cloud, and gives you consistency and a high degree of automation. And you would want to leverage modern application concepts for all your applications, whether they are old or new. That means you build better software architecture, you make it future-proof applications and modularize them, you adopt agile integration, which will help you build the bridge between old and new applications, with using those concepts of decoupling, exposing and integrating, managing APIs, integration that works with and in the cloud. Then you need to streamline application lifecycle so as to speed up the application delivery. Last but not the least is the continuous innovation. DevOps principle and collaboration, okay, needs to happen so as to get a faster, okay, path from idea to production. So basically the vision is to move the monolithic setup to microservices based over a period of time. This means many microservices now represent various functionality that were coded within the legacy applications. There can be more reusability. It also means separation of concerns, and microservices do one job and do it well with whatever the best technology that is available. In legacy, one is forced to have a homogeneous setup within a construct of a legacy application technology. Also, the data availability, creation, consumption, scaling can all be delegated to individual microservices, thus simplifying the architecture. Likewise, for representing a flow, be it a business flow, integration flow, or automation flow. So let us now explore some use cases where there is a definite benefit of using modern architecture. Partner integration. A media service provider like Comcast and its affiliated work with various partners. This business-to-business partnership needs to cooperate and amplify their reach to gain more customers and revenue. For this, some ways can be by finding or creating new channel and revenue sources. And for that, it is necessary to integrate with partner systems quickly and try new things sooner, accommodating customer needs. With modern architecture, you may want to monetize certain partner relationships or interfaces, which might have been difficult with legacy setup. Using standard interfacing and multiple choices helps in ease of integration. The next use case is basically about customer integration. There is a big demand from customers to accommodate their needs related to access to their own data through various services you offer. Example, some data might be in CRM, some about purchase histories, some in preferences that they have defined somewhere, and some in billing etc. Making the same data available in various forms over different channels creates an opportunity to serve your customer well and create loyalty and stickiness. The next use case is basically about enabling customer facing apps. So another big is from customer is about omni-channel experience. Having a consistent, reliable experience while consuming services over various interfaces and devices like say phone, web, text, mail, kiosk, voice-based digital assistants, and approaching through various third-party partner systems. This creates a necessity of developing a robust integration architecture, account for service reusability, and a faster deployment. I may want to go a little bit deeper onto that particular one example related to that, which is customer engagement hub. So there are customer events which are happening on one end. So depending upon those customer activity, some events are triggered and there is a need to integrate with other various interfaces with different protocols, collect that data, transform it as needed, have some kind of an intelligent system that uses business rules to create an appropriate response or trigger appropriate process or task, and a data handling mechanism that works with a data flow. This also involves integrating with existing legacy systems or data sources, and then appropriately take an automated next best action or provide a response back in customer's preferred channel. This is how you engage the right customers via their preferred channels and with relevant content and offer that you're giving them. This also brings a very interesting emerging use case about sentiment analysis. So there are more complex requirements of doing a deep analysis of customer interactions. For example, buying pattern, service consumption preferences, regional aspects, or a feedback received say over a social media or some other means. So your modern architecture and integration components should assist the new army of data scientists that are working to create such sentiment analysis related models faster, test them quicker, and produce working models to yield best strategies for efficiency and revenue generation. And talking about data scientists, here's an example of what a typical data scientist expects. Their focus is on accessing a rich set of modeling frameworks, data and computational resources that they can then share and collaborate with colleagues and partners to find ways to drive business value. So basically enabling these highly efficient data scientists to do their work even more efficiently and not be bogged down by collection of data, availability of data, or complex integration. The modern framework will be able to help them do their activity much faster and yield much better results. So let's talk about the understanding this modern architecture. What does it mean and what does it comprise of? But before we go there, okay, first let us agree on modern application concepts. IT revolves around building better application software architecture, which is future-proof, can bridge communication between old and new applications, do it much quicker and in a highly innovative and collaborative manner by embracing agile culture. For this, the early steps are to be to modularize, be it fast moving monoliths or a brand new application based upon microservices based architecture. Modularizing along with decoupling and suitable integration frameworks will help in creating API centric services that become infrastructure agnostics, thus facilitating portability. The process with optimized CI/CD automation and goodness of container technology provides the desired optimization and efficiency. The three main pillars of transformation are basically modernizing the platforms, modernizing the applications, and automation. And these are the pillars of transformation, but they are all interlinked. We are at a stage where containers technology plays an important role in supporting these three pillars of transformation. Red Hat understands this, and hence we promote not just digital transformation but open one, wherein you choose best of the breed technology, which are not only highly innovative because the way they have been developed using open source software development, but also comes with a backing of Red Hat support and ecosystem support that comes with it. But first, let us knock off some basics here quickly. The old applications were truly monolithic. Then came an era of service-oriented architecture. It had its own benefits, but also some pitfalls, and was not suited well for the big business and technology disruption that came next. So now, with the amount of disruption that is happening both at business and technology level, we are at a stage where microservices architecture makes much more sense. So let us cover this relationship with the interlinked infrastructure. All the earlier talk about modularity, scaling, etc. has really pushed us to not only create smaller independent microservices, but also to expect more density from infrastructure to support that isolated compute capacity for these microservices. This is where the microservices and containers are like made for each other. The density, isolation, flexibility, scalability provided by container technology is unprecedented. This has accelerated a move towards microservices adoption. The containers and microservices feed each other and are two important wheels which will keep the modernization vehicle moving forward. Let us cover the area of developers for a bit. Current enterprise application market is focused on some well-established technology areas, .NET, Java EE, simpler application servers like Tomcat or frameworks like Spring or some legacy application servers. However, there is a rapid and definitive shift towards more modern runtimes and frameworks, which are naturally well suited for modern needs. Some examples like Node.js, reactive programming like Vertex, microfile specification, program, or which will be based upon Java EE development. Let us review some principles of cloud native container design quickly. So of course, as I mentioned, the microservice needs to do one thing right, so they are kind of a single concern. There needs to be a need for high observability, like what the container health is, whether it's up or down, whether it is ready, whether it is live, whether it is collecting matrix and all the logs. The next is about lifecycle conformance, whether you could stop and start it based upon actions and APIs. The next is about image immutability. This is a very critical aspect. You may build something which is to be run on a container in one particular environment, like a dev environment. How do you ensure that the similar setup is running in another environments like QA and staging and production? So that image immutability separates that particular part of defining the image on which the container instance is run and the running instances itself, which makes it easier for you to build once and deploy many times, that kind of concept, so as to maintain reliability across various environment deployments. The next is about process disposability. We have ability to stop and start your services based upon the container instances they are running. And the last but not least is the self-containment. That means you do the building part, the other aspects of configuration and storage and network and all those things are separated out which means that for the whole container instance, it does that particular functionality what is expected out of in a self-contained manner. And then let's talk about cloud readiness part of it. So there's a lot of terms over here: cloud native, cloud compatible, cloud ready, OpenShift ready. By the way, OpenShift is Red Hat's container technology platform. We'll cover that in a bit of a detail, but let's clear this terminology. So there's often a confusion between these cloud related terms. Cloud native means it's distinctively built upon cloud related architectural principles and characteristics. Cloud compatible is something which may not have been built, but by its nature can have a minimal viable sense of running on a cloud environment. And cloud ready is something which could potentially you could make and lift and shift, and it has now eventually become cloud ready. However, the most important part is to understand that not every application should or can or must be cloud native. Container ready is often enough. So you may run modify a certain application by changing its runtime, or just lifting and shifting it and make it container ready. However, the primary focus on technologies like container platform like OpenShift is adoption instead of high re-architecting effort, so that you have a quick entry point, gain on the success, and then eventually expand on that. So let's talk about cloud native application ideals. The first, some of the characteristics of a good cloud native applications are ability to horizontally scale dynamically with easy loading of configurations. Then also account for and pull all dependent services and libraries that it needs. Then also have ability to manage traffic by effective load balancing and delegation. And then have an easy way to manage, like doing a monitoring, logging, tracing, health check related things. So journey from cloud compatible to cloud native. So eventually some things might be cloud compatible, but you may want to make it cloud native. So you can do the cloud compatibility by doing just lift and shift, but it may not make that application truly cloud native. So some of the steps that you can take to make it cloud native are slowly and surely try to externalize your configurations, eliminate anywhere you have done some hard coding, whether it is related to hard dependencies on certain infrastructure aspects, or running it on a standardized, and then eventually you may want to run it on a standardized operating system like Red Hat Enterprise Linux. Now let's talk about why Red Hat. Well, the technologies and practices to get there exist, but let me show you how this helps, like from a Red Hat standpoint. Now this is a big eye chart. However, this just depicts that Red Hat has all the technologies that you think you will need for this. So at the bottom of this particular cake, or architecture, layered cake, is the infrastructure that it supports on, right from physical, virtual, private cloud, or public clouds like Google, Amazon, Microsoft Azure, or any other cloud providers. These are the core infrastructure that you can run the systems on. On top of that, what we provide is the infrastructure software, whether it is Enterprise Linux, or whether it is storage solution, or OpenStack solution, or Red Hat virtualization. And on top of that, the most important part is the container platform. So Red Hat's OpenShift container platform will run on top of it, and on top of those will be your application runtimes, or your integration related runtimes, or business automation, process automation related runtimes. Now what are these runtimes? Basically, when we talk about application runtimes, it's about any runtimes or frameworks or technology concepts that are needed to develop and run and execute your applications, whether it is about Spring Boot, whether it is about Java EE based applications, web server based applications, or your existing Java EE based legacy machine application server like JBoss Enterprise Application Platform. The next is, as I said, when you break up a monolith into smaller microservices, there's a tendency of achieving a lot more integration between them, and this is where the integration components which will come in handy. So integration services like based upon Apache Camel, which will help you achieve the mediation, data collection, data transformation, data mapping, or using any messaging technology to act as a messaging backbone to transmit a message in a point-to-point, or publish it in one-to-many, or do it in a brokerless type. And then third aspect of integration is basically exposing these services externally using API management solution, where you will be able to do some traffic management, do some monetization policies, access control policies. The next part I had spoken earlier was about the intelligent piece, and this is where the intelligence part is taken place. So any business logic which changes frequently and is better authored by collaboration between business users and the technical people, that's where rule engines come in. So having a robust business rule engine helps a lot, and this is where Red Hat provides you Decision Manager, which is your business rules engine. The next part, similar to the business logic, is about the business flow. If you are able to enable your business users to model this particular workflow and then able to execute them, that will help a lot. Optimization solution is basically able to optimize about allocation of resources or finding the shortest way and those kind of use cases where you cannot do with the traditional programming. Last but not the least is basically the core services, whether it is about having a Java runtime available, whether it is about a single sign-on or particular web server connectivity or any connectors that you're talking about. And on top of these runtimes is what you run the your microservices. On the left hand side you can see the developer tools which you can use, and on the right hand side is the security and management, various Red Hat tools, technologies available there. Now let's talk about why change with Red Hat. A migration to Red Hat's middleware, which was the main part of the various runtimes I spoke about, and the container platform, which is the OpenShift in the earlier slide. This will help you with many benefits. So it delivers more than cost savings. It sets the stage for be able to create more agile computing, thus allowing the IT organization to respond more quickly to business demands. And these application migrations, often in conjunction with application infrastructure modernization, they will let you firstly rebalance your maintenance and innovation, and then decrease complexity, increase efficiency, and this is a big time benefit that you get. It also helps you reducing the vendor lock-in, or helps you increasing speed and hence become more productive with state-of-the-art technologies. It helps you remove technical debt and the risk associated with your old legacy systems, and you get all of this much faster from idea to production, and are able to innovate by applying agile and DevOps principles and collaboration. Now, how do these benefits materialize? Most of our customers have been using proprietary middleware before moving to JBoss, and they are seeing a great difference. There is a very interesting study by IDC commissioned by Red Hat. IDC interviewed a number of real customers. While numbers may vary based upon your individual situation, it's a great guidance to give you an idea about what a migration of JBoss middleware can mean to your organization. So what we see consistently is a reduction of development time and higher productivity, and a more reliable infrastructure and massive cost reduction, which means that large-scale migrations are typically paying for themselves within less than a year. If you are interested in the business case, you can always look at the link in this particular PDF, which will be shared with you later on. And no matter what architecture you choose for your applications, what programming language the developer finds most useful, and what services you want to use as building blocks, OpenShift Container Platform provides you a single and consistent development model across the build, test, deploy, monitor, and review lifecycle of the application. This will provide you with a self-service infrastructure. Now this lets the developer provision what they need on demand and skip waiting for hours, days, and sometimes weeks for infrastructure resources. This also provides a consistent environment. OpenShift makes sure that the environment provision for developers and across the life cycle of application is consistent from the operating system to the libraries, runtimes, version, etc. And even the application runtime in use, like say Tomcat, is used in order to remove the risk originated from inconsistent environments. The next is basically about automating build and deployment. So OpenShift gives a choice to developers to build their containerized applications themselves, or to have the platform build containers from the application source code or even binaries. Now the platform then automated development of these applications across the infrastructure based upon the characteristics that the team has defined for the apps. The example like how much resources should get allocated, or where on the infrastructure they should be deployed, or how they could be compliant with third-party licenses. The next benefit, of course, is a continuous delivery pipeline. OpenShift provides out-of-the-box support for CI/CD pipelines so that the development teams can automate every step of the application delivery process and make sure it's executed on every change that is made available, made to the code or configuration of the application. The next benefit is a configuration management, where configuration and sensitive data management is built in the platform to ensure consistent and environment agnostic application configuration. And this is provided to the application no matter what technology is used to build the application and any environment it is deployed on. Last is about the application logs and metrics. Now, rapid feedback is an important aspect of application development. OpenShift integrates the monitoring and log management, providing you with immediate metrics back to the developers in order for them to study how the application is behaving across changes and be able to fix these issues as early as possible in the application lifecycle itself, and not wait for very elaborate QA stages and performance testing and all those things to be completed. Now let's talk about building the next generation applications. This is where some of the new concepts about building the new next gen applications comes in, like Istio based service mesh, which will help you for separating the concerns, like using you can have enhanced security and network segmentation of microservices been defined separately from the core application part itself. So this will help you in combining some of the goodness of open source technologies like Istio, Kiali UI, and the Jaeger for tracing. And the serverless is a concept wherein you are now integrating and enabling scale to zero function as a services and event sources built on top of an open source community project called Knative, which is now inbuilt in OpenShift. You can also have support for something like public cloud provided functions like Azure functions, and then integrated with CamelK for rich set of initial event sources, like for support for HTTP, Kafka, or AMQP like protocols. This brings in enabling greater developer productivity. Like in terms of developer tools, what we provide is something called as code ready workspaces, which provides an Eclipse J based developer ID that is tightly integrated with OpenShift. Code ready workspaces provide support for developing teams to build applications together. But even if you are using Visual Studio Code or IntelliJ or any other IDE, OpenShift plugins will allow you to use your existing tools yet deploy your apps on OpenShift. And for command line users, ODO gives you a very powerful CLI to deploy applications on the command line. From an OpenShift point of view, it's a single product with various consumption models. So models which will give you a choice to customer in order to balance the level of productivity and operational efforts versus the level control they need in the platform. OpenShift Dedicated is a professionally managed enterprise grade Kubernetes by Red Hat on one of the public clouds, Amazon Web Services, Google Cloud Platform, which is coming, and Microsoft Azure, and are dedicated to a single customer with custom setups for private networks. Azure Red Hat OpenShift is a jointly engineered, operated, and supported by both Microsoft and Red Hat with an integrated support experience. The next option is Red Hat managed OpenShift on IBM Cloud, so joint engineering and integrated support by IBM and Red Hat teams. And then the core OpenShift platform, which is based, you can run it on-prem. Basically you manage it. So you have a secure Kubernetes platform on your own infrastructure. Build, deploy, and manage your container-based applications consistently across cloud and on-prem infrastructure. There is also another use case wherein we provide you completely Red Hat managed, even the integration solution for you, what we call as Red Hat managed integration. So what Red Hat managed integration is that just like it's based upon OpenShift Dedicated, so all the services related to OpenShift, underlying OS, network, and all those things are provided to you and managed by Red Hat. On top of that, the integration and application development runtimes that are needed, whether it is related to API designing, messaging backbone, any application runtimes, connectors, or integration related tooling that is needed, plus single sign-on and developer tools, and a solution explorer, which is kind of a guide through for creating the services, is all hosted and maintained by Red Hat. All you have to do is bring your developers with their ideas, and in a very easy manner start developing your applications right away. Okay, so the most important component of RHMI is SLA. As a managed service, the software is only a part of the product. Red Hat takes on responsibility of ensuring uptime, maintenance of the software, and a unified user experience. Now in the next slide, okay, there's a list of the products that provide coverage. So we have Red Hat Fuse, Red Hat 3-scale API management, Red Hat AMQ, Red Hat OpenShift, application runtimes, and all those things are provided on top of Red Hat OpenShift dedicated. It should be emphasized that the services are the same code that is on-prem versions. That means all tried and tested and true Red Hat products are there. Only now they are hosted and managed by Red Hat. So if you start with something which you have managed and start building some assets there, and then move on to Red Hat managed integration, because the bits are same for integration, you wouldn't be making any changes to your any code or application assets that you have created. And likewise other way, you may start your development on RHMI, eventually you want to move it on your self-managed infrastructure or OpenShift environment. You could do that without worrying about compatibility of that applications that you have built on RHMI running on a non-RHMI setup. So typical use cases, innovation zone. If you want to do friction-free development, just bring your developers and ideas and start developing right away, do that. Omnichannel delivery, that means you want a seamless user experience, for various users. Or legacy application modernization, you want to front-end your legacy things with a quick entry point microservices. You can do that so that you can do quick lift and shift and or a pass-through kind of services, and create the API driven in enterprise. So enjoy the benefits about API management, wherein you are not only doing a traffic management to your various microservices that you have built, but also monetize them or do effective traffic management or access control on those particular services. So let's quickly talk about future ready options. This is an interesting area. About so let's take one example quickly about Java. So it has evolved tremendously from plain old applets in 1996 to a modern avatar of fostering applications that are cloud native, microservices based, and account for modern approaches of event driven and serverless. Now if we talk really about the biggest impetus in all of this has received is from containers technology, and they have been a focus of many new discussions that are happening. So which also means that we need to have a various choices, not just for architectural styles like from monolith to cloud native to microservices to serverless and event driven architecture, but also related to the corresponding technology for that architectural style. So for this, the traditional Java was not coping well. Java is slow, has been an old complaint. So challenge was not just to make it faster and leaner, but at the same time support for these various emerging architectural styles. This is where Quarkus steps in. It is a modern Java made for container based needs, but beyond, but it can serve things beyond the traditional, just the normal container based needs. So let's talk about these benefits. The first benefit is obviously it's about made for container. It takes very tiny footprint, which is what the containers would expect, and then it boots up in fraction of time. This is perfect for the way containers scale up and down, and makes it very smoother and faster for your CI/CD processes. The another benefit is for developers. So it is based upon standards, so there's not much of a learning curve. The more important aspect of it is something called live coding. So it's kind of a dream come true for developers to make changes and see them right away, which definitely improves their productivity, and the development experience a great deal. The third benefit is that it unifies various styles of programming. So you can combine both reactive and imperative development and exploit the benefits of each of them, but at the same time they need not be mutually exclusive. This makes it easy to develop precisely the services that fit your needs without compromising on development runtime choices and the styles of invoking those particular choices. The next benefit is primarily about related to choice. So for various needs and so many cloud friendly runtimes and frameworks and technologies have come up, so it's up to you to use best of the breed technology to cater to your needs. All of those work extremely well with the Quarkus environment. Now let's talk very quickly about and wind it up with the Microservices evolution. So Microservices Evolution has matched with the advent of container platform, since most of the routine works, whether it is about configuration loading, routing, tracing, discovery, etc., monitoring, has now been delegated to container platform. The microservices can truly become micro and thus be only focusing on doing the functionality it intends to do. However, the reality is that though the microservices are supposedly independent, isolated in a way, there is also a need to have a communication between each other. So what can a container platform do to facilitate that? As I mentioned earlier very briefly about service mesh. So service mesh is a technology which is based upon Istio, or community project. It uses a concept of delegating the non-core task to a sidecar container, which makes it easy to handle these non-core aspects in a very configurable and pluggable way and keep your microservices running on the primary container really truly lean. Now let's talk very quickly about our approach to application modernization and the best practices. So core principles, let's revise them. So core principles is basically about having a business value driven change. So based upon whatever business needs are there, how you can drive those change, do those things in a quicker, faster way, in a highly efficient manner, eliminate as many risks as you can, and also include all three aspects of your IT: people, process, and technology. However, the key thing over here is that the open innovation, which has been fostered by open source development, will help you unlocking the potential of existing and future applications. Now there are various patterns in modernizing applications. So first one is of course rehosting, lifting and shifting. So you can do is containerize your existing workloads without doing any structural changes to them or any infra runtime changes to them. You deploy them on the platform as a service like OpenShift and keep your external integrations and data on legacy. However, for this your legacy applications have to be well written and suited for this. But this is the quickest way to containerize your applications without doing changes. Now there might be applications which may have runtimes which are not compatible, and changing those particular runtimes may help you in moving them to containers. This is called replatforming or augmenting. So your core structural things remain same. However, as I said, the runtimes or the libraries and all those things can be made more agile, or the DevOps process can be made more agile by moving them to containers. And the last one is about really building cloud native applications, the brand new applications grounds up from being cloud native. So using those cloud native friendly runtimes, technologies, those architectural concepts about modularity, separation of concerns and all those things, you can build a true blood cloud native applications. So whether you choose any of these choices, it has to basically run on any of the environment, infrastructure environment that you're providing. And this is where something like OpenShift comes in handy. It will provide support you to choose any pattern you like out of these three. So Red Hat approach is not just the choice of right technology, but also some key good practices. Like you should be doing information sharing based upon collaborative way, and that's how open source way is, on which Red Hat has built in. The big thing about microservices architecture, containers and all those things is about reusability, automation and standardization. and effectively having a very efficient and proven pragmatic approach towards solving the modernization related challenges. So key part of this is like minimize the changes, doing the risk mitigation, finding a right way to adopt the right container options, containerization options that you may have. So if I have to quickly summarize this, you have a scenario where you would like to run your existing brownfield applications, grow them and slowly move them to containers, and at the same time create a new generation cloud native applications. However, this is where something like OpenShift will come in handy for providing a common hybrid application infrastructure. You have to combine the transformation using the core technology and processes. You have to choose between the right choice of technologies, what applications or servers are suitable, what integration runtimes are more efficient, and what kind of application infrastructure choices you make. Migration to modernization is painful, whether you migrate your apps or augment them to replatforming them. You have to make those appropriate choices based upon your needs and about the flexibility of existing applications and the trade-offs in terms of keeping the application same or rewriting them. The benefits are immense, apart from the price, reducing your cost, unlocking potential for doing things faster, reutilizing your IT infrastructure efficiently, doing things faster, doing collaborative way, and having things and services rolled out much faster to your customers' benefit. And last but not the least, I'd like to end on this particular note, is that hybrid multi-cloud capability is the future need. And from that point of view, the core foundation, Red Hat Enterprise Linux, helps us in kind of building support for various kinds of infrastructure choices that you may have. Whether it's the primarily a homogeneous environment about on-prem or virtualization or OpenStack or individual public clouds, or in future about a very hybrid multi-cloud capability, something like OpenShift Container Platform will be providing you with that agnostic experience, infrastructure agnostic experience for any runtimes and applications and microservices that you built on top of it. With this, I thank you all for listening in, and I hope you found this useful. Now we could go in for question and answers.